Well, now we're going to look finally at the binomial theorem. And before we do that, let's just look at a couple of very trivial examples that things that we could all compute. C plus d squared, well, if I FOIL that out, I get c squared plus 2cd plus d squared. And I'll make a comment on that in another minute, but let's take a look at this one. This one takes a little bit of work. That's x plus y times x plus y squared. So I'm going to FOIL out the x plus y squared, and we get x plus y times x squared plus 2xy plus y squared. And then we need to do a little bit more work with that one. We end up with x cubed plus 3x squared y plus 3x y squared plus y cubed. If you do all the multiplication and then combine like terms, that's what you get. Well, the observation before we jump into the binomial theorem is that this is equal to, think of n equaling 2 here and n equaling 3 here, the exponent. This is equal to 2, choose 0, c squared, plus 2, choose 1, cd, plus 2, choose 2, d squared. I just said think of it as being 2, n as being 2, because in the general formula we're going to be using an n. So notice the coefficients these are what we call binomial coefficients. Since this exponent is 2, the coefficients are 2, choose 0, 2, choose 1, 2, choose 2. And look at this. 3, choose 0, x cubed, plus 3, choose 1, x squared y, plus 3, choose 2, xy squared, plus 3, choose 3, y cubed. Again, the binomial coefficients. When you multiply this out, the coefficients end up being 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And just to repeat something we looked at in an earlier video, remember that 2, choose 0 and 2, choose 2 are the same because 2 and 0 add up to 2. If you're choosing 2 people out of the group, you're leaving 0 behind. If you choose 0 of them, you're leaving 2 behind. So that's where the symmetry comes from. These two coefficients are 1. In this case, they're also 1. 3, choose 0 is the same as 3, choose 3. 3, choose 1 is the same as 3, choose 2. They're both 3. Because when you choose 1 out of a group of 3, you're leaving 3 behind. So that gives us the symmetry of the coefficients. They're bigger in the middle, and then they go down to 1 on the ends. All right, so the binomial theorem. If we've got two integers r and n with this relationship, then a plus b raised to the n is equal to n choose 0, that's the first coefficient, a to the n, b to the 0. Now notice, I didn't write d in this. I could have written d to the 0 if I want to, but d to the 0 is just a 1, so we don't usually write it. But I'm going to write it in this generic formula so you can see kind of the pattern going on. Plus n choose 1, a to the n minus 1, b to the 1. I wouldn't normally write that, but b to the 1. And then some generic middle term could be, the rth term, we'll say, is a to the n minus r, b to the r, plus dot, 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 and I'll go all the way to the last term, which would be n choose n as the binomial coefficient. And then a is going to be to the 0, and b is going to be to the n. So you should verify that both of these follow this formula. In fact, maybe we'll do one more. And just for practice with summations, let's write what this is equal to as summation. Notice, just look at the coefficient. The bottom here goes 0, 1, 2, 3, 4, all the way up to n. So I'm going to use the index variable. I'm going to go ahead and use r. R equals 0 to n. And then it's going to be n choose r. Notice that takes care of all the coefficients. If r goes from 0 to 1, the first sum is going to have an n choose 0, then an n choose 1, n choose 2, going all the way up to the last one, which would be n choose n. And then it's going to look like this. A to the n minus r, b to the r. So that's just two different ways of writing it. This is the shorthand way using the summation, where r runs from 0 through n. Okay, maybe I have enough room, maybe I don't. Let's just see what something like, I'll go ahead and use a and b again. Example, a plus b to the 4th power. I'm going to go way over here. A plus b to the 4th is equal to, just writing it out like this, 4 choose 0, a to the 4th. And this time I'm not going to write the b to the 0, because in this, that's just equal to 1. Just like in the last term, a to the 0 is equal to 1. And notice the first and last terms, this only has an x, this only has a y, this only has a c, this only has a d. Plus 4 choose 1, a to the 3rd b. Plus 4 choose 2, a squared b squared. Plus 4 choose 3, a cubed b. And the final term, 4 choose 4, a to the 4th, b to the 0, which I will leave off. So it's very simple to raise something to the 4th power, especially if you memorize or get quick at computing these coefficients. 4 choose 0, that's just a 1. 4 choose 1 is 4. How many ways can you choose one thing from a group of 4? 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. You could just plug it into the formula to verify those numbers. But if you ever compute them and it's not nice and symmetric like this, then you made an arithmetic mistake. Notice the one in the middle is the biggest, and there is a middle because there's an odd number of terms. 0 through 4 is 5 terms. When you have an even number of terms, like in this case, you get, that's a 0, that's a 3, that's a 3, sorry. That's a 1, 3, 3, 1. So you get two big ones in the middle, and it goes down to 1. This one, you only get one term. The biggest term is in the middle, and it goes down to 1 on the external terms. So the binomial theorem, each one of these is called a binomial coefficient.